covering 9.4, which is composite functions. We're going to learn, first of all, what a composite function is, add, subtract, multiply, and divide them. So the polynomials are going to come back to haunt us, and write and evaluate composite functions. In previous years, I've had students come back from the Composite testing to tell me that it was this was kind of the defining set of concepts for getting into advanced math. This seemed to be the level, or the concept that they wanted you to understand to believe that you were ready for like advanced pre-calc and stuff. So just a little note for you. All right. Wow, it seems like we're missing something here. Function operations. So we're basically going to have operations of multiple functions. So if we want to add two functions, first of all, what's the notation look like? That it's f plus g of x. And what's the meaning? It means I'm just going to take the equation of f of x and add the equation of g of x to it. Subtraction of functions. This is the notation f minus g of x. And what does it mean? It means I'm going to take the equation for f of x and subtract the equation of g of x from it. Multiplication, going to multiply the two function definitions together, and this is the notation fg of x. And then division, f divided by g of x, and that means we're going to divide. And notice g of x can't be 0. These are going to look an awful lot like polynomials. So, which is why we did the polynomials before we did this. Right, let's look at examples. Given f of x is 4x squared plus 3x minus 1 and g of x is 6x plus 2, find each function. So this is asking us to add. So we're going to take f of x, which is 4x squared plus 3x minus 1, and add g of x, which is 6x plus 2. Of course, we want to simplify, so combine our like terms, and we will end up with a final answer of 4x squared plus 9x plus 1. All right, this is same definitions, but in this case we're going to subtract. So again, just write the first equation. Again, just like polynomials, you're subtracting the whole equation. So you've got to distribute this. You're going to end up with 4x squared plus 3x minus 1 minus 6x minus 2. Combine your like terms, and you end up with 4x squared minus 3x minus 3. I think that's a pretty straightforward concept. Okay, here is one for you to try. Do a subtraction of those two function definitions. All right, now we're going to try multiplication. So this says multiply f of x and g of x. So we're going to take, so hopefully remember our superfoiling, 6x squared minus x minus 12 and 2x minus 3. And this means multiply each term in this equation by each term in this equation, and then combine like terms. So here they've got 6x times 2x minus 3, a negative x times 2x minus 3, and a negative 12. And now they're going to distribute. And we did this different ways. We had some people set up the boxes, and you can do it horizontally, vertically, and that kind of thing. However you want to do it is okay. So that gets you to, this gets you to 12x squared minus 18x squared. This one is 2x squared plus, so don't forget that's distributed this negative to make this a plus 3x. And then we have negative 24x, and again a positive 36. Combine our like terms. We've got 2x squared and 2x terms. And finally you end up with this. So this is just like polynomial multiplication we had a couple chapters ago. All right, now they want us to divide, and remember Note any domain restrictions that may arise. So when we get to our equation, we want to make sure that we explicitly note any values of x that are going to make it undefined. All right, so we're going to take f of x, which is 6x squared minus x minus 12, and divide this. And if you didn't get it in polynomials, hopefully you'll get it a second time. So first thing we want to try and do is see if there's any factoring we can do. And they love to start us out with complicated ones. This actually, well, I'll just show you here. This actually factors into 2x minus 3 and 3x plus 4. And if you'll notice, we've got that on top and bottom. So it actually simplifies to be 3x plus 4, but we have to note before we cancel out that the denominator can never be 0. And so what values of x are going to make this undefined? When x is, when x is equal to 3/2. So don't forget you put not only the final equation but any restrictions in the domain. All right, another function operation uses the output from one function as the input for the second function. This is called composition of functions, excuse me, or composite functions. Okay, so composition of functions. Composition of functions f and g is notated f composition, or f little circle g of x. Or, so these are both equivalent. You can see it this way or this way. This is a little circle, or f of g of x. So just be careful. I know people get a little bit confused between the two notations. And it can be confusing. F g of x, which is a multiplication, versus the composition, which is f of g of x. So that's just a little point to take into account. So the domain of f of g of x is all values of x in the domain of g, such that g of x is in the domain of f. And that probably means nothing to you, and I wouldn't worry about it. This kind of is a picture to explain which may or may not help you. So this shows you that here's your g of x function, and so if you have a value of 1, g transforms it and you end up with 4. If you have a value of 3, g transforms it to 6. And here, and what does it look like it's doing? It looks like this g of x is just x plus 3. And then f of x takes the output of g, so this is f of g of x. So you work from the inside out is what it's showing you. What you would do is find the value of g of x first, and then you're going to take that value that you get from g of x and plug it into f of x. So now we're going to take the values that we got by adding 3 to x and transform them using the function rule for f, which in this case it looks like it's multiplying x by 2. So it says if you wanted to find f of g of 4, and that's how you pronounce that, f of g of 4, I mean f of g of 1, you're going to find g of 1 first. So we're working from the inside out. So you're going to look at this part first, evaluate g of 1 to get 4, and then we're going to plug that into f to get 8. And so it says f of g of 1 is the same as f of g at 1, like this. And if you think about it, if we have f of 2, what does that mean? It means replace x with 2 in my equation. What does f of g of 1 mean? The same thing. It tells us, whoops, I have one too many parentheses there. This is telling us find the value of g at 1 and replace x in function f with that value. Composition f of g of 4 or f of g of 4 is read f of g of x, f of g of x, sorry, or f of g of x is read f of g of x, as I said. Oops. Okay. So here's our two functions. F of x is 2 to the x, g of x is 7 minus x, find each value, f of g of 4. So remember, we're working from the outside first. So first thing we're going to do, you kind of pretend that this part doesn't exist here, and you're just going to pretend this is your only function to start out with. So we find g of 4 by plugging 4 in for x, and that's going to give us 7 minus 4, or 3. Now we're going to replace, so f of g of 4, we're going to replace g of 4, which we just found to be 3. So now this is going to be f of 3. And we plug 3 in for x, which is going to give us 2 to the third, or 8. So f of g of 4 is going to be 8. That's our final answer. G of f of 4. So notice it's not going to be the same, or it may not be the same. This time we're going to start, we're going to pretend this is all we have and find f of 4. Plug that in, and that's going to give us 16. And now we're going to replace f of 4 with 16, because that's what f of 4 equals. That's going to give us 7 minus 16, or negative 9. And that's our answer. So the order that you do them in is important. The order that they write the function in is the order you have to do them in, but from the inside out, not from the outside in. All right, you find the value of f of g of 3 here. Let's see. Okay. Given f of x is x squared minus 1 and g of x is x over 1 minus x, right? Each composite function and state the domain and range. All right, so it asks us to find f of g of x. So what does that mean? That means we are going to replace, so just like if we have f of 4, that means, this means replace x with 4. F of g of x says replace x with g of x, or the equation of g of x. So wherever we have x, we're going to replace it with this instead. So again, when you have a notation like this, this means replace x with whatever you have in parentheses. So that means I'm going to replace this x here with x over 1 minus x squared. And I would just leave that function like that. All right, so domain, do we have restrictions on the domain? We do, because we can't have this be 0. So they've actually simplified this. I don't think it's necessarily, I would be okay if you just left it like this. But you're going to see 1 minus x equals 0. If I add x, 1 equals x. So if x is 1, it's going to be undefined. So the domain is all real numbers except x, which easy way to write it is x not equal to 1. So it means it can be everything but 1. Does it say? Oh, it doesn't say the range. So just the domain. So that would be the complete answer for that particular example. All right, where are we at now? Given the same set of functions, we want to do the opposite. We want to have g of f of x, so that means we're going to replace x and g with x squared minus 1. So each x, which is here and here, gets replaced. This can get simplified because this is going to be x squared minus 1 over 1 minus x squared plus 1, which is going to be x squared minus 1. We have negative x squared plus 2, or 2 minus x squared, either way. All right, do we have any domain restrictions on this? Well, we're going to see x equal to 0, add x squared to both sides, and you're going to get 2 is equal to x squared, square root it. Are we going to have any values that make that undefined? No, there's no value that's going to actually, well, yeah, actually it is. It's going to be x is equal to the square root of 2. So when x is equal to the square root of 2, you square it, you're going to get 0 in the denominator. And they actually should be positive or negative 2. So it would be x not equal to positive or negative square root of 2. All right. I think the next is for you to try. So given those two, I want you to write the composite function and state the domain of that function. And I think that wraps up composite functions. Here's your homework, and please bring any questions to class.